Welcome. In today's class, we shall be looking at how to go about solving problems involving indices and logarithm. And to go about that, we shall be looking at some questions from WAEC, past questions. If you go through WAEC past questions of mathematics, you'll find out that indices and logarithm are common or recurring questions that you would always find year in, year out. So let us just go straight to solving our first problem. It says evaluate 3 raised to the power 4 times 27 raised to the power minus 3 all over 3 raised to the power minus 4. Taking a look at that expression there, we can find out that there is a common base that we are looking out for. And that common base is 3. We have 3 raised to the power 4. Then we have 3 raised to the power minus 4. Then we have 27 raised to the power minus 3. So what does that tell us? It tells us that we have to convert that also to the base of 3. So to do that, we know that it will become 3 raised to the power 4 times 27 is the same thing as 3 raised to the power 3. 3 times 3 is 9. 9 times 3 is 27. So we represent that as 3 raised to the power of 3. Now, I would like to put this in a bracket so that I can also put the other power outside of the bracket. Good. All raised to the power of minus 3. So this is now going to be all over. We have 3 raised to the power of minus 4. So how do I simplify? I can clear out this bracket I put there. So that becomes 3 raised to the power of 4 times 3 minus 3 times 3 is going to give me minus 9 all over 3 raised to the power of minus 4. So I can now apply my law of of indices to this. Remember our first, second, and third law of indices. When we have multiplication of numbers that have a common base, we do what? We add up their powers. When we have division of numbers that have a common base, we do what? We subtract their power. So this can be written as 3. This can now be written as 3 raised to the power of 4 times 3 raised to the power of minus 9 divided by 3 raised to the power of minus 4. Hope no magic there. Okay, so I can proceed also. Now, based on my law of indices, I could collect all the powers. Whether it is if it's multiplication, we said we are going to be adding powers, and if it is division, we are going to be doing what? Subtracting the powers. So this is going to be represented as 3 raised to the power of 4. That's 3 raised to the power 4 times 3 raised to the power minus 9. So what do we do there? We add the power. So that's going to be plus minus 9 plus minus 9. Then where we have divide, we say what do we do there? We would subtract. So minus 4. Are we following? Okay. So now we have plus into bracket minus. Plus times minus is minus. So that's going to give us 3 raised to the power 4 minus 9. Minus times minus is plus. We have minus 4. So that's going to be plus 4. So this now is going to be equal to 3 raised to the power 4 plus 4 minus 9. And 4 plus 4 is 8. 8 minus 9 is minus 1. So this is equal to 3 raised to the power of minus 1. So we can still represent this. It says evaluate. You can still represent this as being equal to 1 over 3. Question number 2. Simplify the expression log 3 base 4 times log 4 base 3 plus log 32 base 2. If we look at the left-hand side of this expression, we'll find out that we have an operation on the log of numbers that are having different base. And a law of logarithm says that if we have an expression like this, log x base y, we can convert that to another base by converting it to, let's say we want to convert it to base 10. It is the same thing as log x base 10 over log y base 10. So if we apply this formula to our expression above, log 3 base 4 becomes log 3 base 10 over log 4 base 10 times log 4 all over log 4 base 10 all over log 3 base 10, all into brackets, plus log 32 base 2. Now, I can resolve this. I can see that something is happening there. Log 4 base 10 can cancel out log 4 base 10. And then log 3 base 10 can cancel out log 3 base 10. So that becomes 1 times 1, and that is 1. So we have 1 plus log 32 base 2. Now, from here, I can see that log 32 base 2, 32 is the same thing as 2 raised to power what? 2 raised to power 5. So I can represent that to become 1 plus log 2 raised to power 5 base 2. Now, based on the law of logarithm, we can move this the power of 5 back to log, and that becomes 1 plus 5 log 2 base 2. Now remember, the log of any number base that number is equal to what? 1. So this becomes 1 plus 5 times 1, and this is going to be equal to 1 plus 5, and that's equal to 6. So that is the answer. Okay, number 3 says if log y base 10 plus log x plus 3 log x base 10 is equal to 2, express y in terms of x. What this is actually telling us is that we should make y